Our next speaker is James Simmons. He works at Oak Ridge National Laboratory. On the piece of paper here, it says he's been an active Linux kernel developer since 1999. This development has spanned from small embedded systems to large supercomputers. James has been active in the Lustre community since joining RNL in 2008. Okay, so here's the take-home message. This guy works so hard. You know, I'll check my email and you know, doesn't matter, day, night, whatever. I've got in my inbox like zillions of messages from this guy because he's been working on the upstream client. I mean, you know, if you guys are on Lustre Devel, you see it, you know, you go, this guy, he's a machine. So I'm really looking forward to hearing what he has to say about his life as a machine. Because you know, I don't know whether I'm envious or what. I mean, you know, maybe I need more coffee. James Simmons, you rock. Tell us what it is.
Thank you, thank you. Today we're going to discuss where we've gone in the last year from last time at LUG. So now we are at the state where we have two trees. We have the OpenFS branch, and we have the upstream client now that's functional. So since last LUG, when we started, after last LUG, we started to venture into working with the upstream client. So a little backstory of the history. So it was merged in 2013 by EMC. It was branched off of just before the 2.4 release was done. And it went up. It was active actually for about 6 months, and then it just kind of waned and then just decayed for 2 years. And this led to incredible rage from the upstream guys. And when I became actively involved after the last LUG, and I asked, what do you want to have done? Anyone who saw the mail saw the hate. It was quite aggressive. At that time, they gave us an ultimatum of 2 months for deletion. And they said, if you don't make any substantial progress, it will be deleted. And then we actually pulled it out. And then again, at the kernel summit, there was discussion about its removal. And at that time, it was ramping up our development on the upstream branch. And it was decided to keep it in. But now today, we actually have good standing with the upstream developers. Greg is quite okay with us now. Patches get merged in within a few days. So the big changes that have happened is that there was required to move ProcFS to sysfs. That work was done. We've done huge, massive check patch cleanups. This is one of the things that really griped them. There were over 6,000. Today, there's a little under 1,000. We also updated our tools, which was all integrated into 2.8, so it could actually use, because of the ProcFS to sysfs changes, none of our tools worked, so we could not do any testing for any substantial period of time there. Now we can actually test. We also I've been merging the stuff from the libcfs cleanup on our side with the cleanup they've been doing. The biggest change of all, actually, is LNet. So the biggest change is, one, is we've made the upstream LNet layer independent of Lustre, so you can configure it by itself. So this way you can use Lustre 4.6 or above on your LNet routers, just the kernel. So that way, down the road, when RHEL 8 comes out or whatever distros, you won't have to do any special work on the routers as it currently stands. So as I said, starting with once 4.6 is released, the LNet layer is now completely compatible, and all the integration and every fix and changes that we've done to LNet are in the upstream client. And also, because of this work, there has been interest now from other Linux kernel developers to actually move LNet out of staging first, and they've been asking what would be needed. These are the things they would like to see done to have it moved out. So now that we have an actually useful upstream client, now we have to actually start testing it and making it really functional. So the things we have to do is to make sure that it actually behaves most properly. So we have to integrate it with all our Malu stuff. So we've been working out the test failures, thanks to the work of Andreas mostly, and to skip some of the functionality that we don't have. So this way we can use what's there. And we do have some test failures because there's some things that are just not working in the upstream client. So that's one of the steps we're working on now. The other thing is now that we have had moved everything up to LNet layer in the upstream client. Actually, the flow is actually going into the OpenSFS branch. This is the first time for us, so now we're starting to land stuff. And so we're actually seeing progress on both fronts. We're seeing actually a convergence of the two. So because of this, there are some challenges with the changes that you have to do for the upstream, which I'll go over. So the big thing is when you submit patches, this is a reference to what the work is being done now, we still have Lustre client code going up patches. So we have the biggest bottleneck for staging is the one change rule. So every patch has to be the simplest, simple change, one little thing. If you rename a variable, that's all you send up if your patch does that. If you indent, send that up. So you have to break up. Usually the average patch that's submitted to master is broken up into 5 to 15 patches. So that's quite a lot of work, but that's what we have to do right now. The other thing is that we've done is we've actually considered the kernel coding style. It's now the style for the OpenSFS branch. So these are some of the guidelines for submitting. The other thing we recommend that people do when they create their patches for master now, please run check patch from your kernel source to make sure the patches are, because this will make life so much easier for when we port upstream. So here are some of the differences. So for the developers now, and this is one of the things now that we do have LNet and libcfs, that's pretty much in sync. It would be really nice if me and Oleg aren't the only ones pushing all the patches. That's a heavy burden. So when you do this, please consider some of the changes and I wanted to go over the differences with what you are normally used to working as a developer versus what we've done. So the things that they are okay with is the 80 character line thing. They're more relaxed than actually the OpenSFS branch. So if you're gonna break variable names in half, that's not cool with them. They would rather be able to read it. The other thing is we have a lot of error handling like LCE errors and LConsole. They rather have the strings not broken. So that's another thing they've asked for. And the reason, their logic is quite simple. The reason is if there's an error that the system administrator sees, they want you to be able to gripe for it in the source code and to find the actual string. And if it's broken, that makes it a much more challenging job. The other thing is they're really relaxed on header style. So they're not too crazy about that, so you don't have to kill yourself at making it 80 columns and stuff. And there's actually been debates about what should check patch even ignore header files. So a couple other issues when you're doing a patch, no spaces. No spaces with variables in any way setting them. In a lot of our code, we have this int and then this big, long street to get to the house at the end. And it's the same with setting the variable. So don't do that. And no generic naming. This drives them absolutely bonkers. No go-to out. No go-to B. Please don't do that. They actually want you to define what's going on if go-to out, error, allocate, or something like that. The other thing that has been that's considered kernel style that we haven't done is we like to do lots of returns and functions. They rather have go-tos to the end and just one return at the end of the function. So please don't do if this fails, return. If that fails, return. And they just hate that. And of course, we've had errors, but this is actually much better now, is they want actually the return values, they want them actual return error codes, eval and stuff, no -1. And the other thing that actually drives them batty is some of the code that we have does error, it does success handling. So if it checks if a function succeeds and does it, they would rather have us look for errors to be in a logical, consistent way. So that's some of the major stuff that we've gone over. I've actually created a wiki, and it contains all the data about how to contribute, how to set up the upstream client code, how to set up your Git configuration so you can push patches up. So everything's there, and I've completed all that information. So what were some of the things that gave people heartburn in the OpenSFS branch? Well, we had this discussion, and it was the pointer testing for null. That's one of the things that upstream said, well, we really don't want you to do that kind of style format. And it's not the greatest style, I have to say. I prefer the style that OpenSFS did, but it was voted on before in a majority rule kind of way, and there was no logical reason. So we're stuck with it, and we've determined that this is how we're going to actually do this. This is probably one of the ones that, if you look at the code in OpenSFS branch, it's kind of a mix between these styles because nobody knew what to do. So this is the official policy. It's the kernel style. And then we discussed this at Developers Day about doing that. And we don't have to worry because we talked about the issue. If we didn't do that style, how do we submit patches? There are a couple things that will remain, like entry and exit macros that we use for stack tracing and stuff in the OpenSF branch that won't be in the upstream client. All right, so that's where we're at for now. So this is to give you an overview of how to push patches and stuff now that it's actually a viable thing. So what's the future work? We still have libcfs. In this case, libcfs is behind the upstream client. So there's still lots of wrapper abstractions that we have to do. There's the debugging is kind of messed up in a way that libcfs headers are still being pulled into userland utilities because of, oh, geez, I'm almost done. So that was one of the things we discussed. The other thing is, of course, is pushing the illustrated client code changes that we have to upstream still. We just recently pushed up the Clio simplification work from 2.6. So we have this hybrid kind of 2.6-ish kind of upstream client. And the other thing, of course, is we have to deal with debugging. Trace port support, memory leak detection in a standardized way, and we discussed this, enabling using ftrace versus KEDR framework, which might be a possibility. So this is actually what's the remaining goals with Syncing Master with the upstream client. So these are the people involved. Oleg and John Hammond and Dimitri have been involved. Ben Evans from Cray, thank you for cleaning up all the Lustre include headers. And Frank Sagos, and of course myself. And of course the goals, those are all the goals that we have lots of technical debt to remove. And various things like macros to be pulled out because they hate those kind of things. Kernel styles, we've been dumping lots of tab nastiness onto the master branch. And of course, the abstractions that's being done for libcfs and the cleanup that's being done by Ben Evans from Cray. And of course, we continue to do better support for newer kernels. Currently, we're up to 4.2 is completely supported on server and client side. There is work being done for the long-term support release, which is 4.6.6. And of course, we're constantly doing more bug fixes from the upstream down. So, and then of course, we have master's progress. So since that time, as I was saying, we're marching toward 4.46, and we have tool support for the upstream client, and we have the coding style enforcements and the flow of, and also the data flowing from upstream back. And of course, Ben's work and libcfs has continued. We're ripping off the last few Band-Aids. So, and then the other things that we're preparing as well is the server side. And like we said, we want to do patchless servers. And we need to prepare all these things. So, and eventually, we want to actually dump the server code upstream. So, and we're also looking for LDiskFS being pushed upstream. And we have support for 3.18 LDiskFS from Cray that's done that work, LU7311. And of course, we need the packaging system because right now, well, it doesn't really build against upstream very well. And of course, for the Intel branch, what do we need? Check patch audits. We need to backport all the CFS support back to the OpenSFS branch, continue libcfs killing it off, and of course, Ben Evans' work, cleaning up the Lustre headers so they're UAPI compliant. And of course, we need to rework the build system so we can actually build utilities only against the upstream client. And so the conclusions this year, it was a very successful year. We went from being hated to being liked. And that was a very big deal. I mean, it was almost deletion a few times, I mean. So it's a very big deal, that change. And of course, I hope for 2.9 we'll finish off a lot of the libcfs cleanups, the last bits, the abstractions we have. Hopefully, we'll finish up the Lustre UPI headers, and the kernel will sync up through the final style sync ups is left for LNet. And of course, the upstream client, that's the huge push. Right now, we're at like 2.6 hybrid, and we're going to fill in the gaps of patches that were missed and bring it up to date. So the goal is to bring that into sync with what we have. And of course, we'll continue to support the latest kernels. And hopefully, by next slug, everything will be synced up between both branches.
Thanks, James.